So in this video, this is part 3 of inverse functions. This is going to be the last video that I talk about just the concept of inverse functions before I go into some more specific types. In this video, I want to get you guys to understand the relationship between a function and its inverse, and I also want you to be able to determine the inverse of a given one-to-one function. I'm going to talk about that with one of our examples down below. So first and foremost, how are f of x and its inverse related to each other? Well, if I have the domain of f of x is set A, and the range of f of x is set B, or some intervals, then the domain and range are going to switch. So that means the domain is going to be now set B, and the range is going to be set A. This goes back to the concept with inverses that it switches the x's and y's. It undoes the original process. Furthermore, the graph of f inverse of x is a reflection of the graph of f of x over the line y equals x. Again, just going back to the idea of switching the x's and the y's. One other thing I want to talk about is how to fix a function that is not one-to-one. So normally, we really want our function to be one-to-one so it has a nice unique inverse. But if it's not one-to-one and we still need an inverse, then what we're going to do is we're going to take the domain and we're going to cut it down. We're going to restrict it in such a way that it does become a one-to-one function. So I'm just going to cut off anywhere that it actually repeats. That leads me into some examples. So let me go ahead and scroll on down. This first example set we're going to talk about says the graph to the right of the function f of x equals the square root of x plus 1. And we want to sketch the graph of its inverse. So a couple things that I need to do. First, I'm going to identify some points on this graph, on this curve, that are easy to do. Like, for example, 0, 1. I'll do one there at 1, 2, and I'll do another one over here at 4, 3. And so if I want to graph the inverse, all I'm going to do is switch those x and y values. So for example, if I start off with 0, 1, that's going to give me 1, 0. If I go to 1, 2, that's going to be 2, 1. And if I do 4, 3, that's going to give me on the inverse the point 3, 4. Let me go ahead and draw my curve. Okay, notice at 0, 1 we had an endpoint, so at 1, 0 we're also going to have an endpoint, and it's going to keep on going through. The original went through 4, 3, so this is going to go through 3, 4. Question 2 says draw the line of symmetry on the graph 2. So the line of symmetry is y equals x. That passes through the points 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc., etc. So there's my line of symmetry. I drew it in green. A couple of things to point out is if the original curve touches the axis of symmetry, that line of symmetry that I drew, the inverse is also going to touch that point. If the original function is above the line of symmetry, the inverse is going to be below the line of symmetry. If the original function is below the line of symmetry, the inverse is going to be above the line of symmetry. It's a nice, pretty reflection. Let's see, a couple other things we need to talk about. So number 3, the graph of f of x has only one y-intercept. That's here at 0, 1, which means that the inverse, if I switch it, it's going to have only an x-intercept. The same idea applies if I reverse it. So if the original function has an x-intercept, then the inverse is going to have a y-intercept. They just switch. Also, if f of 16 equals 5, which it does, because the square root of 16 is 4, plus 1 gives me 5, then f inverse is just going to switch them. So notice in this case, the x value was 16, that's going to be my y value, and the y value was 5, so that's going to be my x value. So again, they just switch. A little bit of a different question on a separate note, because all these went together. Let g of x equals 2x plus 1 over x minus 3, and it asks us to find a formula for g inverse. All right, in first and probably most important thing to talk about is that g of x is just another way of writing y. So this is the same thing as 2x plus 1 over x minus 3 equals y. And so what I want to do, again, when we talk about inverses, is just switch the x's and y's. So here's what I'm going to do. Every time I see a y, I'm going to write an x. Every time I see an x, I'm going to write a y. And then I need to solve this equation for y. Since I've got a fraction currently, I'm going to multiply both sides by that denominator to get rid of that fraction. And that should give me x times y minus 3 equals 2y plus 1. I am going to go ahead and distribute that x. So we'll have xy minus 3x equals 2y plus 1. Again, we are solving for y, so I'm going to get all my y's on one side, so move that over. And everything else without a y to the other side. So we'll have xy minus 2y equals 3x plus 1. Then we are going to factor out the y, which gives me x minus 2 equals 3x plus 1, and then divide. And that should be my final answer because I'll finish solving for y. So 3x plus 1 over x minus 2. So I'm going to go ahead and write down that final answer here on this blank. 3x plus 1 over x minus 2. That's my inverse. Let's follow up with one last set of questions, 6, 7, 8. So it says the graph to the left is the function h of x equals x minus 2 squared minus 1. I think I had a typo down here. This should be an h inverse of x. Let's see. How can the domain be restricted so that it is 1 to 1? So one of the things that I'm going to do is I'm going to look for where it switches. So notice this is not 1 to 1 because if I draw a horizontal line, it touches it in two places. So the question is, where can I draw a vertical line? Where can I cut this domain open where if I look at one side of it, it does not repeat? And the answer in this case, since it's a parabola, is to cut it right here at the vertex. And so if I forget about this left side over here, I've now got a 1 to 1 function over here on the right. So I'm going to make my domain from positive 2, that's the x value right here, to positive infinity. And I'm going to use a bracket on that 2, but a parenthesis around the infinity. Now, I'll also point out that another correct answer, because there are actually several correct answers we could have here, would be to forget about the right-hand side and just focus on the left-hand side. Now, in this case, the domain would be negative infinity to 2 with a bracket. Again, it's also correct, but I'm just going to kind of stick with that other one first. So let me erase this for a moment. Okay. Now, again, if I just focus on the right-hand side, the question becomes, what is the range? Well, I'm looking for the range is what y values are being used. Well, the lowest y value is down here at negative 1. And if I follow this curve on the blue part all the way up and up and up and up and see how high it goes, it's got an arrow at the top telling me it's headed toward positive infinity. So my range is going to be from the lowest, negative 1, to positive infinity. Since I've put a bracket here where it is to negative 1, I'm going to put a bracket there at the negative 1. Fun fact, if you reverse it and look at the other side, so instead of looking at the right side, if you look at the left side, you actually get the same answer. Is the lowest it goes is negative 1, and if you follow that blue curve up and up and up and up and up, it's all the way headed up toward positive infinity again. So you're going to get the same answer, even if you had a slightly different domain. Notice it's just flipped. Again, there are quite a few different correct answers, but we're basing it off of what we said for number 6. The last question, number 8, says, what does that make the domain and range of h inverse of x? And so important thing to remember is that the inverse is just going to switch. I'll do it in red. It's just going to switch the domain and the range. So my range will end up being bracket 2 comma infinity, and my domain will be negative 1 with a bracket to infinity. Again, if I chose these two answers, I would do it a little bit differently. Negative 1 to infinity and negative infinity to 2. Hopefully that does help you guys get a better understanding of inverse functions as a whole, and I will hopefully see you guys in class.